Now, from our second question, we're actually given that the space between two plates, two parallel plates, is filled with what? Oil. Each side of the plate is 70 what? 720 millimeter. So basically, you are given the area of the plate because each side of the plate is filled with oil at the middle, and each side of the plate is having 720 millimeter. So this is the area of the plate. The thick of the film is 15 millimeter, right? So this 15 millimeter is given to be the distance from the fixed plate to the what? To the moving plate. The upper plate moves at what? 3 meter per second, and you are given what? The velocity for your moving plate. Now look up, you are now given the force of the plate in what? Newton, not Newton per meter square. When you are not giving Newton per meter square, then you are giving what? Shear stress. Are we together? But in this case, you were just giving force to be what? 120. So it's left for you to get the formula for what? Shear stress, and solve to get your answer for what? Shear stress. Are we together? It is required to maintain the speed. Estimate dynamic viscosity of oil in what? Poise. Kinematic viscosity of oil, given that the specific gravity is what? 0.95. So you are given specific gravity. So what you do is you get the equation for your specific gravity and use that equation to calculate for the density of your oil. Are we together? Now remember, every question has a fluid that will be given to you, and also when considering questions that has to do with viscosity of plate, the first thing that should come to your mind is give the diagram of what? Your plate. Give the what? The diagram of your what? Plate. Now that should be the first thing that should come to your mind. If you want to give the graphical representation of our questions from the value we've extracted for your plate, you simply have your moving plate, right? We have our moving plate and we have our what? Fixed plate. So we have your fixed plate. Always leave your fixed plate to have this symbol. This is always telling the examiner that there is a difference between this line and this line. Now remember, they are aligned what? Side by side, parallel. They are parallel to each other. So this is your fixed plate, which is what? U of what? F, and this is what? U of what? M. Now from our question, we know that U of F, since it's fixed, is not going to have any what? Velocity. So your velocity here will be what? 0 meter per what? Second. But for your moving plate, you will simply have a velocity of what? 3 meter per second. This is what? 3 meter per second. So what you have here, you have a velocity to be what? 3 meter per what? Second. Now the distance from this plate down to this plate is what? 15 what? Millimeter. 15 what? Millimeter. So what you do is you convert your 15 millimeter to what? Meter. Let's convert that. So we have our dy here is given in what? 15 what? Millimeter. So what you do is you convert 15 millimeter to what? Meter, right? So if you convert that, you simply have 15 times what? 10 raised to the power of what? Minus 3 meter. So you've succeeded in converting your millimeter to what? Meter. What's the next thing you are given? You're now given that, let's get the du here. Getting the du, we know that for you to calculate for du is simply what? U of what? M minus what? U of what? F. U of moving, velocity of your moving plate, minus the velocity of what? Your fixed plate. And this will be what? 3 minus what? 0. And what you have here will be 3 meter per second. So this is your du. Are we together? Now the next thing from our question, we were given force, right? And we said the force here is what? 120. Here you impute your force in your data sheet, which is what? 120 Newton. What are we given again? We are given that the area of both plates was given to be what? 720 millimeter. Each plate was given to be 720 what? Millimeter. So the area here, we are given area, and what's area? Area is simply what? 720 millimeter times what? 720 millimeter. And that will give us what? That will simply give you what? 400 millimeter square. This is your area. Now remember, this area is in millimeter square. All values will be using what? SI unit. Convert millimeter square to what? Meter. If you want to convert millimeter square to meter, we'll divide by what? We are going to divide by 1000. So we are dividing this with what? 1000. And if you divide this with 1000, we'll simply arrive at what? 518.4 meter square. Are we together? Now, since we've succeeded in getting the area, we already know force. But remember, from our elementary physics, we know that when we are considering shear stress, which is tal, is equal to what? Force over what? Area. Right? So if you have force over area to be shear stress, we'll simply have that the value for your tal will simply be what? What's your force? Your force is in Newton, 120 divided by 518.4. So you simply punch your calculator and you arrive at the value for your shear stress, which is what? 0.2315 Newton per what? Meter cube. Newton per meter what? Square. Now, observe your values. Always check your values with your calculator. From what I have here, I have what? 0.2315 Newton per meter what? Square. So this is the unit for your what? Your shear stress. Are we together? Now, since we've gotten the shear stress, what parameter are we to get again? I think we've gotten all parameters. Now remember, recall that you were given your oil, your fluid here. Your fluid is what? Oil. Always tell the examiner the fluid that you were given. Sometimes they will assume you don't know the question that you are answering. You are just using ChatGPT to answer your questions in exam. So instead of using ChatGPT to answer the questions, prove them wrong by putting all parameters in your data sheet, so they will know that, oh, you know what you are doing. Now the fluid you were given here was what? Oil. You were given the fluid to be what? Oil, right? So the examiner looking at your data sheet and is seeing that, you even know the fluid that was given to you, then you know what you are doing. Are we together? Now, since we've gotten all parameters, our interest is always to calculate for your dynamic and your kinematic. Are we together? Now, to calculate for your dynamic, we know that dynamic is what? Tal divided by what? Du over what? Dy. Are we together? We already know what's tal, we already know what's du, and we already know what's what? Dy. So we impute those values into this formula and get our what? Dynamic what? Viscosity. Now, if you impute those values, we simply have, what's your tal? Your tal is 0.2315 Newton per meter square. So what you have here will be what? 0.2315, right? Newton per what? Meter square. Are we together? What will be the next value you are going to arrive? What will be the next value you are going to get? So the next value is to get what is your du, right? Now, from what we have here, we know that our du is what? Our du was given to be what? 3 meter per second. So you have your du to be what? 3 meter per what? Second, divided by, what's your y is 15. 15 times 10 raised to the power of minus 3 meter. So what you simply do in your calculator, you first punch 3 divided by 15 times 10 raised to the power of minus 3. After getting your value, then you now punch 0.2315 divided by the answer you got. And that will give us what? And that will give us 0.00116. So this will give us 0.00116 Newton seconds per what? Meter square. Are we asked to leave our answer in pause? Yes, we are asked to leave our answer in what? Poise. So leaving your answer in poise, that is telling you that, recall that we know that 1 poise is equal to what? 1 divided by what? 10 Newton seconds per meter square. Now, in essence, we are to get this value in poise, and we don't know what is this value in poise. So we represent that value to be what? X. And we know that X is equal to what? Equivalent to 0.00116 Newton seconds per what? Meter square. So what we do is we cross multiply. Cross multiplying, we'll simply have that your X will now be equal to 0.00116 Newton seconds per what? Meter square multiplied by 1. If you still multiply by 1, it still remains the same thing, but what will be added will be what? Poise. So you have poise here, right? Now remember, if x is multiplying this, you'll be left with x and this, abi? So what you do is to make x subject, you divide both sides by what? 1 divided by what? 10, which is 0.1. So this will be 0.1 Newton seconds per meter square. Now Newton seconds per meter square, we cancel out Newton seconds per meter square, and you're left with what? Poise. Now remember, you have a value to punch in your calculator. If you punch this value in your calculator, that will simply give you what? 0.0116, and the unit will be in what? Poise. So this will be your dynamic what? Viscosity. Now remember, since we are given that our dynamic viscosity to be in poise, leave your kinematic viscosity in what? Centistroke, not what? Stroke. So what you are going to do is, when you are calculating for your kinematic viscosity, you first get your answer to be in what? Meter square per what? Second. Convert your meter square per second to what? Strokes. Convert your strokes now to what? Centi what? Strokes. Are we together? It's very simple. Now let's do that. For your kinematic viscosity, remember, when we are considering kinematic viscosity, we know that kinematic viscosity, it is the ratio of what? Dynamic viscosity with what? Density. Now, but what you are given here will now be what? Density of what? Oil. Density of oil. Now, recall from your question, you were given that you have a specific gravity. Now, what is now the specific gravity you are given? You are given that the specific gravity was given to be what? 0.9. So you tell your examiner that you were also given, recall that specific gravity was given to be what? 0.95. Do we know the density of oil? No, we don't know the value for your density of oil. Now it's left for you to calculate for the density of what? Oil. Now recall, when we talked about the properties of what? Fluid mechanics, we made mention of specific gravity as one of the property. And I said for you to calculate for specific gravity of a particular fluid, what you do is you get the specific gravity is equal to what? The density of that fluid with respect to the what? The specific weight of water. That's the formula we are to use. Now recall that specific gravity of a particular fluid, but remember the fluid you are given here was what? Oil. So you have to get the specific gravity of oil, which was already given to you to be what? 0.95. So the specific gravity will now be equal to what? Density of oil, right? Divided by the specific weight of what? Water. So you have the specific weight of water, and we know that the specific weight of water is always what? 1000 kilogram per meter square. Are we together? Now what we have here will be what? 0.95, and this will be equal to density of what? Oil, which we don't know, and this will be what? The weight of water, and we know that the weight of water is what? 1000 kilogram per meter square. Now what do? For you to get your density of oil, you make density of oil subject by cross multiplying, and you simply have that density of oil will now be equal to 1000 multiplied by what? 0.95, and that will give you what? 940. So we have 940 kilogram per meter square. So this will be the value for your density of oil. So what you do is you impute this value into your equation that says what? Kinematic viscosity is the product of what? Dynamic viscosity divided by what? Density of oil, which is what? 940 kilogram per meter square. Are we together? So you have that your kinematic viscosity will now be equal to, what is now your dynamic viscosity? Your dynamic viscosity was given to be what? 0.00116. So you have your dynamic viscosity, which is what? Your dynamic viscosity, which is 0.00116 Newton seconds per meter square, divided by 940 kilogram per what? Meter square. And what will you get? You will simply arrive at the answer to be 1.2340. 2340. Always confirm your values. Always confirm your values. From what I have here, I simply have my answer I simply have that my answer here is 1.234640 times 10 raised to the power of what? -6. And what's the unit? Meter square per what? Second. Now remember, you were not done. You were to convert your meter square per second to what? Strokes. Converting to strokes, because you cannot just convert this value to what? Centistrokes. You need to convert it to strokes first before converting it to what? Centistrokes. So to convert it to strokes, you recall that we know that 1 strokes is equivalent to 10 raised to the power of what? -4 meter square per what? Second. So we have that x, since we don't know the value in strokes, we call it x, and x is equivalent to what? 1.234 times 10 raised to the power of -6 meter square per what? Second. So what you do is you cross multiply and you get your answer, which is what? Your x here, to be what? 1.234 times 10 raised to the power of -6, and this will be what? Meter square per second multiplied by strokes, and this will be divided by 10 raised to the power of what? -4 meter square per second, right? So what you have is meter square per second will be cancelling meter square per second, right? So if meter square per second is cancelling meter square per second, you are just left with your strokes. So your strokes now will now be 1.234 times 10 raised to the power of -6 divided by 10 raised to the power of what? -4. And you will simply arrive at a certain value to be what? 0.0123. So you have 0.0123 strokes. Now drop your correct answers on your comment section. Drop all the correct answers on your comment section. If the answers here are very correct, then put a thumbs up on the comment section. Now remember, we're to convert this to centistrokes. Converting this is already in strokes. So we are converting this to centistrokes. Now to convert any value to centistrokes, we know that 1 centistroke is equivalent to what? 1000 raised to the power of -1 strokes. So for you to convert your strokes here to centistrokes, we have that x is equal to what? 0.0123 strokes. So what you do is you cross multiply and you get your answer in strokes. Now let's go to a new page. If you cross multiply, you simply have that your kinematic viscosity in centistroke will now be equivalent to what? 1.23. Remember, what you have there will be what? 0.0123 strokes multiplied by what? Centistrokes. And this will be dividing what? This will be dividing what? Remember, this will be dividing 100 minus 1 strokes. So strokes will cancel out strokes and you're left with what? Centistrokes. So what you do is you punch your calculator, 0.0123 divided by what? 100 minus 1. And you have that your kinematic viscosity to be in what? 1.2340 centistrokes. So this is the final value for your what? Your kinematic viscosity. Is it not very simple? It's very simple. What you do is you know your steps, you apply your steps, and you get your what? Your final answer.